Okay, geographers, going to look at this Lab 8 that you need to complete this week. And so you're going to be covering two separate things in here. We have coordinate systems and land division. I'm going to stress that these are two separate things. Now they're similar in the sense that it has to do with mapping and all of that. And really we put them together in a lab like this because, there's only so much you can do with, something like UTM, which is what you're going to learn today. There's also only so much you can do with something like the public land survey system, which is the land division component. So throw this stuff together so you have a full lab activity. But I do want to stress, because I see students do this all the time, that you don't you don't want to blend these things together, right? So what I teach you here as I go through this and what you're going to read through and what you're going to work on with the coordinate system component, keep that self-contained, right? And then when you move on from that and you move into the land division stuff, it's a totally different thing. So nothing you do in the first half of this lab will carry over to the second half. And I'll point that out as we go through. I just want to make sure that's clear in here because these things don't work together. And honestly, what we're dealing with, I think I've talked about this with at least some of you in the lecture component of the class. A coordinate system it's a grid, right? It's a way of finding a precise location, a dimensionless point somewhere on the globe. Okay, so we're looking for where two lines intersect, and where these lines intersect, that's where we're at. Okay, that's where we want to be, or that's where we're currently at, or whatever. Okay, that's a coordinate system. Land division is when we take some large area of land, like let's say Southern California, and we divide it up into parcels, right? Into property. I mean, you can just think of real estate in general. Think of the, space in which you are listening to this right now, where you're working in your lab, whether it's your home or somewhere else, you're on some piece of property that is owned by someone, right? Maybe yourself, maybe a landlord, maybe the local government, it's public land, whatever it might be. But we've divided up this larger area into lots or pieces of property or whatever. Okay, so with land division, we're not interested in a single point, right? This one place where I'm standing at this very moment, but we're interested in a unit of land, the property on which my house is sitting, or the property that holds the college or the Starbucks, or whatever. Right? Hopefully that makes sense. Okay, so to start with, we're going to get into coordinate systems, and you've already worked with one coordinate system in this lab. We did stuff with latitude and longitude, right? That's a coordinate system. It's two different lines or sets of lines making a grid. And if you have, that latitude value, the longitude value, you figure out where those things intersect, and that's your point, right? That's all a coordinate system is. And the thing to remember is it doesn't have to be latitude and longitude. That's what the ancient Greeks came up with. We, Westerners, we white folks, we got a thing for the Greeks, and so, stuck with that. And that's why we're kind of used to this concept of latitude and longitude when we think about geography and maps and that stuff. And since you guys have worked with it, you've also seen it sucks, right? It's not fun. It's not intuitive. It's all sorts of, it's a fraction of a fraction of its angles, and it's just archaic, right? Which makes sense for a system that's, about 2,000 years old. So we have other coordinate systems we can work with. And the one that you're going to learn today, it's the one that I choose to work with if I'm making a map for field use or actually working out in the field using my GPS receiver to record some kind of data. I use UTM, right, which stands for Universal Transverse Mercator. And I should also state, I don't know if I have any veterans in the class, anybody with any kind of military training, but the U.S. military uses their own version of UTM. And I don't even know exactly how it works. I think they throw like letters in. I think that's one of the big changes. But just be aware it's different from what you've been taught if you have any kind of military UTM background. Okay, and honestly, for a lot of folks who I've had who have been vets, they like didn't even work with it enough to worry about this, so you're probably fine. But I just want to stress that the military uses their own UTM system, which is, as far as I know, different from what we civilians use. Okay, so I'm going to teach you the civilian method. And so with UTM, you can read through here and get a sense of the theory and the background of it. Read through it. Don't get too hung up on it, because really what we're doing here is I want you to be able to apply this stuff, right? Be able to use it. So I'm not looking for you to, by the end of this lab, to be able to teach me the background or the science behind how it works. But the goal is that you will be able to look at a map, find the UTM coordinates, and tell me where something is, right? To be able to navigate with this stuff. That's what we're working toward. But still read through to get a sense of what we're doing. And this, on the second page, where we get into these zones, these different zones that exist around the globe, it has to do with the fact that UTM, it's a coordinate system, but it's also connected to a very specific type of map projection. So think back to the lecture class and talking about map projections. Think to your map projection lab that you've done. This is just another one of those. And it's set up this way. The line of tangency, which refers to where the projection surface touches the globe, and it's where we have the least amount of distortion, right? So it's the area where the map is the most accurate or true to reality, right? What we do with UTM is we have about 60, not even about, it is 60, of these separate projection surfaces that we move around the globe. So the line of tangency moves around here, and they correspond with these zones. Okay, so this map, you can see the US, now it's divided here. So like with zone 15, the idea is when these initial maps were being made, that line of tangency is running right through the middle, right there, okay? And then the same thing, 14, same deal, 16, same deal. So it's a way to ensure that we have minimal distortion, but in order for that to work, you need to know which zone you're working in, right? If you're using a map and all that stuff, okay? So it's good to be aware of this stuff. So this is the why up here, but really these questions are pretty straightforward. So take a look at the map, get a sense of that, but that's the last time you're going to work with these UTM zones in this class. It becomes more important when you start to actually work with the data, make your own maps based on data recorded from the field, that kind of stuff. All right, but that's all that is. Then moving on to page 3, right here, you got a sample map, and this is a USGS, the U.S. United States Geological Survey. Is the USGS. They've made maps of every square inch of the United States, and they're quite useful. And it's a shame that we're not actually in a lab class. You guys can't actually work with the real maps. Instead, you have little, clippings of these things. But they're incredibly useful maps. Not always the most up-to-date thing. And I don't know if we'll be talking about that later, in this class or not. But they're really useful for physical geography stuff, getting a sense of what the natural landscape looks like in a specific area. Okay? And with these maps, like I said, they cover the whole United States, but they've been done with these specific standards, conventions. So if you can be looking at a map here in, Southern California, you can be looking at something up in Alaska, a map of somewhere in Texas or Massachusetts or, wherever around the country. If you can read one of these, you can read them all. because all of the stuff, the colors, the symbols, the different systems in place, like all that stuff is standard. Okay? And so one thing they use as they're making these maps is UTM. There's a UTM grid that exists on here, but it's kind of tricky to read, or you need to know exactly what it is you're looking for. So with these, and it's hard to see, I know, on this screen here, but you should be able to see it on your thing. I don't know when I see my Zoom stuff is freaking out, or focus. Let me see if I can fix that. Sorry, I haven't been looking at the screen, so I don't know if it's been doing that the whole time. Just, sorry if you're getting a headache with this stuff. All right, I think good enough. All right, so with this, like I said, kind of hard to see on the monitor, but on your actual lab that you print out of the PDF file or whatever, what you can see in the circle itself is a little 3 and 2 big 7s. Okay, and then there's it's almost impossible to see in the printout I have here, but there would also be a blue line or blue tick mark in here, that's the actual place where this little is. Okay, and same thing up here. There's a little blue tick mark right there, and it's a little 3, a little 8, a big 0, and a big 6. All right. So here's how we read these. Here's how we make sense of this stuff. And the way to look for it, it's that the way in which they do the tiny little number or 2 at the beginning and then the bigger last 2 numbers, that means you're working with UTM. Okay? Also the blue lines that are in there. The way you work with this is you add 3 zeros because we're dealing in meters. So these numbers actually mean something here. They're meters from this origin point, and so to save space, and plus it kind of looks cool, to do this they get rid of those last 3 zeros, so you just need to know to add those, right? So this little 3, little 8, 0, and 6, we slap on 3 zeros, and what this is really saying is 3,806,000 meters north, okay? From meters north from this origin point, okay, which is down at the equator with this stuff, okay? And then this same one here, the little 3 big 7s, you add the 3 zeros, so it's 377,000 meters east, okay? And convention is when we're dealing with this, I did it backwards, but we read first the easting and then the northing, which is what we call this meters east. It's an easting value. And the way to remember it, it's over, then up. Okay? So if I have some point on the map, let's say I'm interested in this spot, or that's where I am, or that's where I need to go, its location in the UTM system is 377,000 meters east, 3,806,000 meters north. Okay? And so if I'm given those UTM coordinates, I would look to my map and I would find those areas and see where they intersect, and that's where I need to go, right? Or if I'm in a location, say I know I'm like at this exact point on the map, I could actually from here look out and get a sense of what my UTM coordinates are, right? And it's as simple as that. And you might look at this and see these big weird numbers and think that doesn't seem easier than latitude and longitude. But the great thing with this is it's simply meters, right? Which, a meter, it's roughly 3 feet for you Americans listening to this. So we can get a sense of, that unit of distance. And so honestly, if I'm, going up this way, if I'm moving north, my northing value, if I'm going due north, my easting value would be the same, but my northing value would just go up 1 meter for every meter in which I move forward, right, or move north, right? So that's it. And so when you're comparing stuff, you can actually get a sense of how far away something is. It's easy to think about what these numbers mean in relation to another set of coordinates, whereas with degrees, in a latitude and longitude setup, they're not consistent units of measurement. A degree of longitude changes in how close it is to another degree of longitude as you move north or south. So this is just, again, it might all seem confusing and weird as you're going into it now, but this is when you work with this stuff, this is the more user-friendly system. Okay, and so that's it. That's pretty straightforward with that there. Now, as you move forward into the lab, we have a few different questions here. I see my thing is freaking out again. So this is what happens when you don't have a professional studio from which to work. So that seems cool. All right, so with this here, what is located at 243,632 meters east, and it's the little m, big E, meters east. That's how we read that. And then 4,315,218 meters north. So you're given the UTM coordinates with these first few ones here. Okay, and then you're asked, like, what are the UTM coordinates to the nearest 10 meters for Lake Tahoe Community College? Okay, and I said be sure to format properly. It should be written in this way. Easting should go first, then northing, and you should have the little m, big E, little m, big N. Right? That's what I mean by that. So these questions here all refer to this map. It's on the next page. Okay, and so this is another, it's a section of, this one is the South Lake Tahoe USGS topographic map, the 7.5-minute series. This is the best we can do in the absence of you guys actually, using these maps in the lab itself. But this should work, and it should be formatted in the original PDF. This should be formatted to where it's to scale, or to that. The scale is 1 to 24,000. Okay, is the scale in which this was initially drawn. Tried to keep that in place here. Of course, when you print stuff out, as margins change and all that, it might change a little bit, but that was the general idea. And then to make life easier for you, also went in, again, this is really buggy. I don't know why my camera does this, other than that I did not spend that much money on it. So with this, what I did to make it easier for you is I overlaid these blue lines. I put the full UTM grid on here. All right, and what we would do in the classroom, I would have given you guys these little homemade UTM grids that I just print out on transparency paper, this clear stuff. So it's actually a map tool that you can hold on here, and it makes life so much easier. But we're not sharing a classroom. So that's how online is going to work. So you don't have that. Right? You don't have the super easy thing, which you can use. Instead, next best thing is you simply have these lines here, okay, pretty clear in here. And remember, with all of these, you're simply adding those 3 zeros, right? So if it helps you think in that way, you can just go in here, right, and add the 3 zeros as you go through here, right? Same thing on this side. All right, and so that'd be 4,312,000 meters north. North is at the top up here, and this is our easting. And you can see it's increasing in value, right? This is 242,000 meters east, and as we move east, it goes up, and these are at 1,000 meter increments, right? That's the idea. So with this too, you can remember that like in between, directly halfway in between 243,000, 244,000, that would be 243,500 meters, right? In that midpoint right there. Okay, and so you can, do the math, break it into increments of 5. I'm not expecting you guys to get a ruler out and have this, be perfectly in the middle, but you should, you should at least try. All right, let me, say that. It doesn't have to be gorgeous perfection, but try. That would be my thing here. And what you can do too, so if you're looking for something like, this school right here, these individual buildings or the different stuff I'm asking you to find, get a ruler or something. Run it off of here, draw that line and see where it falls. And just do the best you can. But you should come up with an easting value and that northing value, and that's where the thing is located. Or on the other hand, if I gave you that stuff, right, like these first ones, the meters east, meters north, figure that out, right? 243,632. Obviously, like just round, right? Especially without having, actual UTM map tools and stuff like that. Figuring out where that 2 is versus 631 or 633, it's impossible. Do the best you can. And no, with these things, there's an actual thing that's labeled on the map that we're looking for, right? So it's not just going to be, empty nothingness. There should be something in that area. Use some common sense as you go through and look at that stuff. All right? Does that make sense? Okay, hopefully. And that's all you're doing. And then once you get done with that South Lake Tahoe map, you are done with UTM for this lab. Okay, we may be coming back to it. Usually I have my students, when I teach this in an actual lab environment, I get my students comfortable with UTM and we do more with it. I can't remember, since we're online, exactly what we're doing. But as far as this lab goes, once you finish that, you are done with UTM. And so don't do anything in meters anymore. Don't do any over and then up stuff. Now we're going to shift over to land division. So this PLSS, the Public Land Survey System, is the system of land division which we're going to be using for the rest of this lab. And I got into this in the Geodesy lecture. I think I go into how the Public Land Survey System works. So you can go, reference that on my YouTube page, and you can see that stuff and get the full rundown if it's not clear after I discuss stuff here. But we're also going to go a little further with this stuff than I showed to the lecture class. Okay, so read through here, and I'm not going to dwell on this stuff because, like I said, I already have a video on this. And the geodesy thing, if you're not in the class, if you just want to reference it, it should be toward the end of that lecture. I think it's another one of these things. Yeah, I did. I'm talking about it using the slides for a little bit, and then I edit in a very smooth way. Another one of these creepy, bodiless hand things where I'm drawing, the baseline and principal meridian and all that. So you can, look at that, read through this, get a general sense. But as you go through, I've got like questions 9 through 12. They're referencing this map right here. And so those of you who have done it in the lecture class already, you'll hopefully remember that, like with A, which I have in here, there's an example, right? You're simply counting squares. So remember, this isn't a coordinate system, so we're not interested in where lines intersect. Instead, we're interested in the actual squares themselves, right? What's in between these lines. So for A, this township, I would count up 1, 2, 3, 4, 5, 6 squares to the north. And so it's, you can see up here, township 6 north, right? But all of these would be 6 north. So we also need this range value, which is either east or west of that principal meridian, right? So it's 1, 2, 3, 4 squares to the east, so it's range for east. So A is township 6 north, range for east. Okay, and you're going to figure that out with B, C, D, and E. Counting squares. All we're doing. All right, hopefully that's clear. Then, as we move forward over here, this is a section or a diagram of sections. So this is actually that township 6 north, range for east that was like this in A, right? So A right here, we've just drawn it bigger so we can see the 36 individual sections that exist in that township. And all of these have them. So every single township, every single square in this map is divided into 36 perfect sections, right? Each 1 square mile in here. Oh, damn it. I just gave you an answer right there. That's, yay, okay, there. You got, a quarter of a point, whatever that's worth, right there. So yeah, they're 1 square mile divided up because these are 6 miles by 6 miles. And it's important to note too, the numbering is weird in here. So it's 1 over here to 6. So 1 always starts in that northeast or upper right corner and then goes over to the west, all right, or to the left, over to 6, drops down to 7 over here, goes back to 12, 13 to 18, 19 to 24, and it's just going back and forth, okay? And I don't know why it is this way. I do know that this is Thomas Jefferson came up with this system. The guy always had reasons, rational reasons for stuff, so I'm sure there's a very rational explanation as to why this is the way it is. I don't know what it is. We just memorize it, right? And this is another thing where it would be useful to have this memorized if we were doing more work with actual maps. And you can even see, if we go back here, now the South Lake Tahoe one is not the best example because it's a train wreck. Like as you get to the California-Nevada border right here, it's a real mess, and it's issues of corruption, it's legal battling, it's just archaic survey methods and things like that. But the actual border is kind of off, and these red lines that are in here are the public land survey system lines. And you can see some of the numbers, like I think it's a 34, yeah, 33, 34, there's a 2 down here. That references the individual sections themselves. So that's, we would see more of this in class if we were in class, but we're not, so you're not. You follow? All right, but here, this is just that idealized model right there, okay? So that's how these sections work, and we would simply, have, I think the example, yeah, it's like, section 36, this area right here, we would list it as section 36 of Township 6 North, range 4 East. Okay, that's again, we're just getting more refined location, a smaller area in there. Okay, then no, that's still not enough. We still have to divide sections. So now this diagram here is that section 36 of Township 6 North, range 4 East that we just saw. But now we're doing what we call aliquot subdivision, okay? Which means dividing stuff into equal areas or equal units, okay? So in here, try to do this not hideously, okay? This first one, so we're going to look at where we divide the section into 4 individual quarter sections. Okay, so ignore all these other little dashed lines. We're just concentrating on this. So we've got 4 individual quarter sections. And what we're going to use, keep in mind, never, ever smoke weed, right? So you're at the lecture class. That's our mantra here, pass on grass, kids. But also helps us remember north, east, south, west. This is important because we divide these up into we use the direction to help make sense of which quarter section we're talking about. All right, so like A right here would be the northeast. Okay, so let's do this quarter, comma, of section 36, comma, Township 6 North and range 4 East. Okay, so it means not only section 36, but this northeast quarter. This one down here, if we had something here, so we'll just make sure that's clear. this would be the southwest quarter. Okay, this would be the southeast quarter. This would be the northwest quarter. And so if you're asked to find something like A right here, you just divide it into these perfect quarters, and you think, okay, what quadrant is it in? Use your cardinal direction. All right, so far so good. But then what we do is you see stuff like B and C right here. We continue to divide it into quarters and quarters of quarters and stuff like that. But keep in mind, we're not getting into eighths or 30 seconds or anything like that, which would be technically true in some cases. But no, what we're actually doing here is like we'll do with B. Now we're dividing it up here with these guys. So what you want to do is work from the smallest unit out. Okay, so ignore everything else on here. Okay, and ignore that C stuff as well. If we're just looking at these 4 squares here, B is going to be what? The northeast quarter, right? Because if we have north up here, I'll just do it, and east right there, and south right there, and west right there. Okay, hopefully this is clear. So in that case, yeah, northeast, that's where B is. Okay, so the B, now let's bring this out over here, would be the northeast quarter, comma, but then, so that's northeast, but then we move out and we look at the bigger picture, and it's the northwest quarter of these original quarters, right? So it'd be the northwest quarter, and then the same section 36, township 6 north, range 4 east. Okay, so that's the idea. We've got an extra quarter in here because we're zooming in more. And it has to do with the purpose of this, in that it's about land division. This was a way to either sell or give away farmland to just average American citizens. And when I say average American, of course, we're talking Tom Jefferson. So that means white dudes, free white men. So what we're talking about, all men are created equal, but it's the free white men that actually get the stuff. So that's the idea. So we don't want these massive, plantations at all. The idea was for just simple family farms. So we're making these small little units of land in which just a normal-sized family can comfortably manage the stuff and grow enough food to survive and all that. That's the original goal with this, right? So B is the northeast quarter of the northwest quarter of section 36 of township 6 north, range 4 east. Okay, C, same kind of idea. I'm not going to draw everything out. Hopefully it'll be clear as you go through here. But just looking at it, let's see, it would be the northeast quarter of the southwest quarter of the northwest quarter of section 36, township 6 north, range 4 east. Tom Jefferson, what a genius. Yeah, so there you go. And I don't know, can you hear my children yelling right now? I told them that, Dad needs to record stuff, so let's keep it down. And yeah, they're clearly murdering each other. But, and if you can't hear it, well, you're missing out because it's good. The little guy is pissed. So I'm going to wrap up here in a bit and make sure no one's dead. But before, so we got that stuff. Just this last one with this, just so you know, sometimes if there's some, body of water, say, that goes in and it ruins the whole farmland idea. Sometimes these things get divided into halves. It's a rare thing, but it happens. So D, just so you know, would be the north half, okay, because it is a half of the southeast quarter of section 36, township 6 north, range 4 east, right? And the lake itself, this remaining land, would be called lot 1. I have that in here. So lot 1 of the southeast quarter, section 36. You rarely see that stuff, but it's there, right? Just so you know. So what you're going to do in playing with township and range, the public land survey system, is you've got A through J, and you're just going to go through here and figure this stuff out. So keep in mind, A and B, all you can give me is the township and range value, right? It's going to be township something, range something, again, just counting squares. C and D, you're going to give section something of township this, range that, and keep in mind too that so this is coming from this specific township right there, right? So once you figure out, once you count the squares, whatever your township and range value is for C, you're going to have the same township and range for D. It's just going to be a different section, right? So you don't have to keep doing it over and over. Now, all these guys, this is the fun stuff. This is that aliquot stuff. With these guys, it's all this section here. And keep in mind, whatever the township and range of C or D is, it's the same township and range, right? So you're going to have a lot of repetition as you go through here. But with F and G, you're going to have, that stuff, this quarter of that quarter of whatever. So just remember, go from that smallest unit out to the largest, and it should work for you. Okay? So work through there and double check, and just keep in mind the order in which you write these is important. If I go back here, like this one here, if I swap northwest and northeast, so if I put the northwest quarter of the northeast quarter, that would actually be a totally different spot, right? That would actually be this guy right here. If we were to, divide this up, this would be the northwest quarter right there of the northeast quarter. So it would mean something totally different, right? Just keep that in mind. So smallest to biggest, if you keep that in mind, that'll help you do this properly. Okay? But with this, go through there, and then finally, the bottom, we're going to figure out how many acres are we dealing with. And so one is given to you, so you can work from there, right? It's just some pretty basic math to figure this stuff out, right? Either multiplication or division, depending on which way we're going, okay? And then on the back, you can do 25. I've already kind of said some of this stuff, but you can also Google, see what happens. And then this very last one, we're not going to do because we don't have buddies because we're doing this online, right? So just skip that one. End at question 25 here. You do that, you turn that in, you're set. All right, I'm gonna go yell at some kids right now. But feel free. Well, I'll still be checking my email in between yelling at children. So you have any questions, just let me know. All right, good luck.